Tomorrow you have a quiz on sections 1 through 4 of chapter 8. So there are some of you who are missing one or more of these assignments. It'd be a good idea to get those in tomorrow. As a reminder, that's what the classroom policy states, is that homework should be in by the date of the test to receive any credit for it. Especially since this is the last week of the quarter, you want to make sure you're not ending it out with zeros. This will be the last quiz or test grade that goes on to this quarter and semester. And then we'll have a couple more homework assignments this week to kind of wrap that up. But since those are only homeworks, they're smaller portions. This is your last kind of bigger grade that's going to go into the second quarter and first semester. So the first thing that you should be able to do is to be able to simplify square roots. After each one of these bullet points of objectives, there's some guidance on some homework problems that you've done that you could go to again and study. A lot of students think you don't need to study for math, which is not really true. It's just different than studying for like history or Bible, okay, or biology. So in those kind of classes, you can read your notes, and that's a good way to study, by reading the definitions and learning them that way, or learning the ideas of history or something that way by reading them. Reading math is not a good way to learn math. The only way to learn math really is to do math. So these sections of example problems I would suggest going to and practicing, especially the odds, because then you'll be able to check them in the back. But these would be the types of problems that you would see, and the best way to study math is to do math and practice that way. So you'll need to be able to simplify square roots, something like if you have a square root of 75, we don't want to give a decimal approximation, we want to simplify it. We want to break down that number inside to be as small as possible, but without actually changing the value of the problem. So we do that by looking for any perfect squares that divide into it. So 25 is a perfect square, and 25 times 3 is 75.
You always put the bigger number first.
It doesn't really matter. I usually put my perfect square first, but it doesn't really matter. Give either way. The square root of 25 is 5. The square root of 3 is not a nice number, so that just stays the root. The goal in simplifying square roots is to make the number underneath as small as possible, and we do that by dividing out any perfect squares. You should also be able to simplify square roots of fractions, and this is by rationalizing the denominator. That's a fancy way of saying no square roots on the bottom. Okay? So when you have a square root of a fraction, the first thing we want to do is separate it so it becomes a square root of a top over a square root of a bottom. And we are not supposed to leave square roots on the bottom of a fraction. So we get rid of it by multiplying by that root that's on the bottom. We have to also multiply the top by that exact same thing, so that we're only multiplying by 1, because otherwise we'd be changing the value of the problem. We don't want to change the value, we just want to change the way that it looks. So on the top then, we can multiply those together. Get square root of 56. On the bottom, a square root times itself just gives us the value underneath. That's why we multiply it by itself, is so that the roots cancel and just give us the value underneath. 56 is a pretty big number. That means that root probably breaks down, so we want to think about any perfect squares that divide into 56. 4 times 14 is 56. And the square root of 4 is 2. And then our last step, since this is a fraction, we can reduce. That 2 and 8 can reduce to leave a 1 over 4. Questions on simplifying square roots, either in and of themselves or as a fraction. This one kind of had both of those things happening in the same problem. First, we took care of the fraction, and then we had to simplify the root itself.
How would you do it if there was like a number and you have the square root again?
If there's a number in front of the square root, so if we have something like 3 square root of 288. We're just gonna let that 3 hang out and deal with that 288 thing on its own and say that that is 144 times 2. And that 144 would give us a 12, which then we would multiply by the 3. So if there's something outside already, we just let it kind of hang out in the front until we have something else outside to multiply it by.
Is there like a number in front of a square root that has a fraction in it? So like
It could be, and then, I mean, you would do the same thing with it, just let the fraction in front, just kind of hang out, and then multiply it by anything else that comes outside. You need to know how to find a geometric mean, which means you need to know what geometric mean means, okay? You don't have to write any definitions for this quiz. There won't be anything that I'm telling you to actually write out a definition, but if the directions say, find the geometric mean, and you don't know what that is, then you can't do it. So geometric mean is a square root of a product. So for this type of question, you're going to be given 2 numbers, for example, 3 and 4, and asked to find the geometric mean of them. To find the geometric mean of 2 numbers, we do the square root of the product. Product means multiply them together. And then for every single type of problem on the test, if you end up with a square root, you need to simplify it if it can be. Okay, not just when the directions specifically say simplify, but the reason we learn to simplify them is so that then we can do that as a regular practice. So to simplify this, we look for a perfect square that divides into 12, which is 4. And the square root of 4 is 2. So a geometric mean is a square root of a product. So we multiply the 2 numbers together and take the square root of them. The next part of the note says that we need to be able to use the right triangle and geometric mean formulas, which means we need to actually know them. They will not be provided for you. So in our notes, we had a picture of some stacked right triangles here together, and we labeled the pieces with various letters. And you were given 3 formulas to find these lengths. These formulas will not be given to you, so you do need to know them, and then you will need to be able to use them.
You have to like memorize the triangle too?
A picture will be given and you'll be asked to write the formulas that apply to it. One way that I try to remember them is not necessarily thinking about all the letters, because I'll end up mixing up letters. That's just something I'm going to end up goofing up where I put the letters in the formula, but thinking about what these formulas say in words. So the first one is talking about that altitude or height, and the altitude or the height uses the 2 broken pieces, the 2 pieces that it breaks up. D and E are really talking about the same thing. They're talking about the legs or the sides of the outside triangle. And both of them say, take the piece that's close to it times the whole side. So for D, B is close to it, and then the whole side is B and C together. For E, C is close to it, and then the whole side B and C together. You have less to memorize if you think about them that way, instead of just thinking about random letters. Think about a side as being close times whole, and that covers either D or E. Okay? So the sides are the close thing times the whole part. Then you're going to need to be able to use these formulas to solve for some certain values. So let's say we had this picture. We would then need to choose the appropriate formula based on what we know or want to know. So since in this one I want to know the altitude, that's like knowing A, and I would use that A formula, the first one, which says that the height is equal to the square root of multiplying the broken pieces. 2 times 8 is 16. And the square root of that is 4. Or so we have this. So we'll still use the 2 and 8, but this time I'm going to look for one of the sides. And this is where I don't think about letters A, B, C, D, and E. I think about side is equal to square root of close times whole. So I use the 2 because the 2 is close to the x, and then the whole side is the 2 and the 8 put together. Some people have a gift of memorizing, and you're fine just memorizing those formulas, but that's not one of my gifts, so then I have to think about what those rules are saying instead of just trying to think about random letters that I'm going to end up getting messed up. So I add up those pieces and get 10. Multiply by the 2 gives 20. We always want to simplify roots, not just when directions specifically say, but anytime you get a root as your answer, you want to simplify it if you can. 20 is 4 times 5, and the square root of 4 is 2, so we get 2 square root of 5. One more. Again, on this one, I'm given a side. So I would think about my side rule, which says side is equal to the square root of the one close to it times the whole side. When your variable is underneath a square root, the first thing you need to do is set it free. If it's stuck under there, you can't do anything with it until you get rid of that root. And the way we get rid of roots is by squaring both sides of the equation. So squaring the 9 gives 81. And on the other side, the only thing that squaring does is take away the root. It doesn't change anything that was underneath. Then I'm going to distribute. Subtract 12. And kind of ran into my other problem here. Divide by 6.
Why did the 6 change to a 2?
Yeah.
Good question. Let's try that again. Bad copying is why that happens. Okay, and then 45 divided by 6. See, we can reduce them both by 3 and get 15 over 2. So questions on those formulas or how to use them? Okay, after teaching this class for, I think this is like my 8th or 9th year teaching this class, I can say with confidence that in the past, many students do not learn these formulas, which means there will be a large number of questions that you will get wrong. Okay, there's no way to do these problems without the formulas. So please learn from the mistakes of students past and study those formulas, making sure that you know them and know how to apply them.
No last one, because your answer would be like a decimal.
Yeah, as long as it's not like a decimal that goes on and was really messy. So that one would have been 7.5 is fine. Pythagorean theorem. You need to know the Pythagorean theorem. A squared plus b squared equals c squared. And know how to use it. In using it, it is very important that c is the hypotenuse. C is not just the thing you want to know, C is the hypotenuse. So in this problem, the hypotenuse is 9, and that means 9 has to be the thing that is alone. That is the most common mistake that students make with this, is just always putting the thing that you want to be the thing by itself. That's easier. I totally agree. That is easier if it's over there all by itself, but it's wrong. Okay? So the hypotenuse always has to be the thing by itself. If you're going for the hypotenuse, then that's fine. If you're going for one of the legs, you need to make sure the hypotenuse is still the c value all by itself. So I get x squared plus 36 equals 81. So x squared is 45. And take a square root to find x. Always simplify roots when possible. 45 is 9 times 5, which is 3 square roots of 5. Questions on the Pythagorean theorem? You need to be able to decide, given 3 numbers, what kind of a triangle they would make. And this is the converse to the Pythagorean theorem. This is where we test and see, does a squared plus b squared equal c squared? And if it does, it must be a right triangle. If it doesn't, then we have to decide, is it acute or obtuse? So, if my numbers are 6, 8, and 10, I'm going to test the Pythagorean theorem. C has to be the biggest one, all by itself. So 10 squared, and we want to decide, does that equal 6 squared plus 8 squared? 10 squared is 100. 36 and 64. Add that up, and we do get 100. Since it worked, that means that those sides would form a right triangle. The biggest one by itself, and the other two on the other side together. Squaring gives 169, 121, and 25. Adding up gives 146. So your not equal means this is not a right triangle. Is it acute or obtuse? Obtuse. The single side was too big, which means our angle was too big, which would be obtuse. It is easiest to determine the acute or obtuse case if you put the C over on the left. Okay? It'll work either way, but then that inequality is going to point in a different direction can be kind of confusing. If you, as a rule, always put your C over on the left, then you're going to see greater than, which will mean obtuse. If you see less than, it would mean acute. And that's easier to keep straight what's what. Okay? We're comparing the thing that was all by itself to the other two. Questions? The last thing you need to know is what we talked about in our last lesson, which is those 30, 60, 90, and 45, 45, 90 triangles. These are patterns that need to be memorized for the long term, because these are going to be incredibly important to us as we move forward into trig, which will be the next few weeks of this class. Will also come up again in Algebra 2. If you go into pre-calc, will also come up again in pre-calc. Trig is going to be something that's going to keep on coming up over and over in math, and it is going to be based on these two triangles. So in a 45, 45, 90, the two sides are the same, and the hypotenuse is square root of 2 times as big. In the 30, 60, 90, everything is based off the short leg across from the 30. The hypotenuse is twice that, and the longer leg is square root of 3 times that. Carefully memorize these triangles. Again, having taught this class for a long time, I can say, in the past, many students have not memorized these triangles, and there will be then a large portion of problems that you can't do. Okay. You need to know these two triangles. Be careful with that 30, 60, 92. A lot of students mess up which one's double and which one's square root of 3. So make sure you're keeping those straight. The hypotenuse is double, and the longer leg is the square root of 3. So in solving problems with these, like in the assignment from last night, if we have one side of a 45, 45, 90 triangle, we know the two legs will be the same, and the hypotenuse is square root of 2 times as long. So I take the side that I have and multiply by square root of 2. In the 30, 60, 90 triangle, everything's based off the short leg. So if you don't know the short leg, that's the first thing you want to find. So the relationship from the short leg to the longer leg is times the square root of 3. So if I'm trying to get back to the shorter leg, I want to do the opposite of timesing, and I want to divide by the square root of 3. I'm not supposed to leave a root on the bottom, so we need to simplify this by multiplying by the root on both the top and bottom. Top gives 6 square root of 3, bottom, a square root times itself just gives us that value. And then we can reduce down and get 2 square roots of 3. Then our pattern, our theorem says that the hypotenuse is twice of that shorter leg. So I want to multiply 2 square root of 3 by 2, and I get 4 square root of 3. Okay, we just multiply the outsides, we don't multiply what's under the root. Questions? Okay, I really cannot emphasize enough that it is very important that you study for this one. There's a lot of stuff that has to be memorized for this. So study and make sure you have it memorized. Practice and make sure that you can actually do the problems. This is your last quiz or test grade on the quarter, so you want it to be a good one.